Happy to see so many are here. Welcome to this presentation on a beginner's course on catalog-driven development. My name is Johan Serebrink, and I've been working with Configura for just shy of 2 years now. A lot with catalog-driven extensions and the hybrid concept. I'll be talking about how to augment a strictly catalog extension with code and if you want to take a look at the material that I'll be working on here, we're going to see a few demos in Emacs. That's available on custom developer conferences, Vegas, November 2017, and then catalog-driven extension, basic. So, let's get started. I'm not going to be talking about how to set up catalog. I see that as a separate topic, and we've had a few sessions on that earlier today. So in this presentation, we assert that we already have a catalog. It has products, and we want to modify the behavior to suit the extension we want to create. Catalogs are great for starting up an extension. You quickly get a viable product. You can keep all your stuff in one place. It handles 3D, it handles 2D, and you got your domains, you got your features. So it's a good start, but eventually in an extension you're going to feel like, okay, so since this is a specialized product catalog, you're going to run into limitations. You can't do everything in catalogs, and that's what we're here to talk about. Catalogs come with a few, as of right now. I'm always speaking about the current state of the catalogs, not necessarily what it's going to be in a year or half a year. Catalogs is constantly under development, of course. One of the things that we right now have something of a caveat with is feature dependencies. If you set up, for instance, you have 3 different products with different modes, and you want to say, and all of them can have colors from a domain, say red, green, and blue to make it easy. The triangle shape, though, should only allow blue color, for instance. Then you have to set up different feature domains, and especially if you then have something that's dependent on that, you're going to be spending a lot of time creating a lot of features. It's all described as a tree in Catalog Creator, and I'm sure many of you know that those trees can become very big. We can easily disable some of these behaviors for CET through Proxy. You know, don't display everything. We can append invalidations if you select the faulty options, and we're going to see some examples on how to do this during this presentation. Another thing that's currently not available, very much supported in catalogs, is the snapping behavior. You have like male-female connectors. It's a bit like puzzle pieces, but you cannot check whether or not another connector on the same snapper has snapped something straight out of the box of the catalog creator. So if you have a strictly catalog extension right now, you're going to need to do some programming to set up that logic for connections. Calculation view is another thing. If you, for some reason, might not like the default settings, you're going to have to do some programming to sort that out. But it's pretty easy to do pretty major changes, and we're going to go through them. So what I've done is I've set up an extension that I'd like to show you guys. Let's see here. It's a little bit difficult to see the screen here. Here's a strictly catalog extension. I made it so that we can place a rocket and And naturally, this can be anything. These are data symbols, and the library is just a table of contents from the catalog. And the different data symbols here have different options, so we can swap it to orange. The engine section, for instance, can have blue fins, etc., etc. This middle section has a length domain too, which we're going to look into a bit later. So that's the extension we're gonna use for this demo. Let's see here if I can make things work. There we go. We have two main ways of overcoming the limitations of Catalogues straight out of the box. Those two are setting up proxies, which is, I would say, the easiest way, but it's somewhat limited. It works towards an interface, and if something isn't implemented in that interface, then you're not going to be able to do things through the proxy. We're going to look into it more in detail. And the other one is to implement fully blown PGC snappers, where we just steal things from the DSP data. We ask the DSP data, get me the 3D, give me articles, the parts that we want to show in the calculation view or the materials, and we're going to look at an example of that as well. Proxies. Proxies work in that way. Every DSP data has a proxy. There's always a default proxy. I think it's called the DSP data proxy. How it works is that the snapper, if it's a data symbol, it asks the data, give me the part, and then the DSP data asks its proxy, should we use the default, or do we want to make any modifications on the parts we have here? And then it sends it back to the DSP data, and that's forwarded to the snapper. So it's basically, it asks the proxy on what to do, and we can define our own proxy, which means that all the things that DSP data or the data symbol snapper asks the DSP data of can be accessed through the proxy, and we do not need to set up another snapper. We do not need to set up a subclass of the DSP data either. It should work by just appending a new proxy to the data that we are using. Do we have any questions on so far on this? Okay, good. Some of the things that we can change through proxies as of right now are Boolean settings, just true or false. Do we want this? Do we not want it? We got part modifications, and that's, you know, we want to change the part that we display in the bill of materials. Or we can change quick properties. Do we want other quick properties? Do we want more quick properties? Do we want to change the domains of the quick properties that we're seeing? And this is where the color thing came in. Maybe if we have a certain model with a certain setting, we don't want to see all the options, and this is available as well. Among other things, I think it's possible to append invalidations also. We're going to look at how to set up a proxy. First thing we need to do is we need to subclass the proxy, the DSP data proxy, and then we need to register the register or append the register. And what that does is basically, for your certain catalog, it hands out which proxy each data should have. So it's we need two things basically. Okay, so let's see here. I'm going to take a look at my screen here, and we are going to try and bring it up on your screen as well. Let's hope this works. So here I've set up a data proxy. As you can see, we subclass it from the DSP data proxy, and we've done a few changes here. And we're going to go through the changes and some of the things we can do. Here's a simple thing that many people would like to do. As per default, you allow option changes in the bill of materials as of right now, which means that if you place a data symbol from your catalog into the drawing and go into bill of materials, you're going to see a drop down there where you can change things. This might not be the desired behavior and we can turn it off. In this case, the engine section, we want to be able to do this. For all the others, we do not. And in some cases here, like this if statement, might not represent the best coding practice. I've opted for readability during this presentation, so don't take every of these implementations. That's the best example on how to implement this. But it's pretty easy to read this at least. So if we have the environment, we check the DSP data on that environment. If we have this product code, the P engine, then true, show the options. And I'm gonna pull up the calculation view so that we can look on how this works. So here we have our parts. The engine section should allow changes. And as you can see here, we can change it from blue to red, and now the part should be red. The other ones do not. So this is a typical Boolean example. So the snapper asks the DSP data, do we want to change, do we want to allow this change or not? It goes back and voila. That's it. So it can be pretty simple to work, and you have the interface. So you kind of have a guideline on what you can do and what you can't do. Where's the mouse pointer? There it is. Okay, so this is a basic example. Another thing we might want to do is change the sidebar properties, or the quick properties, as it's known in other areas. For the middle section, as per default, we have 3 different lengths. This could be a table, it could be a rocket stage, it could be anything, but in this case we have 3 different lengths as a default property on it. And for instance, if we bring up the extension again, if we don't have something on top of it, like this, we might want to be able to change the length of it. But if there is something connected on top of it, or there could be any other relationship or a setting out there in space that makes us want to change it, we can disable it. So in this case, I've done if it's free, we can change it, and if it has something stacked on top, then we may not, and we only show the option that has been selected. So now we're going to take a look on how this can be done. The properties in the sidebars that come straight out of the DSP data is formed like a tree, and we return the sidebar properties from this tree that we want to display, and we can remove the parts of the tree that we don't. Those familiar with how catalogs work know that it's all a tree structure with features and options and the selections, and that gets reflected in quick properties. We go into the pen here. I've made a check, a Boolean check. Do we want to limit it or not? This one check. Is there something connected on top of it? And if there isn't something connected on top, if we don't want to limit the options, it's just going to pass on, return false default behavior. If we do indeed want to change the options, we have written a method here that you can check in the code that then removes the part of the tree that we don't want. We're not going to go that much into detail here. And it returns true, and when we then come back to this thing, if the output for this method is true, then we're going to use these properties that we've appended, and we get the result that we can see here. And this is another thing. We do it in the proxy. We don't have to change the snapper. We don't need to change the DSP data. It's a quick way to do minor changes. Do we have any questions on this so far? Is there anything else you'd like to ask, or we're going to move on to another area? Right. Parts too. We can select for each data object. We can return other parts. Now we just return super. I haven't set up an example of how to append parts, but you can just add more parts, other parts. Maybe you have some sort of table that adds parts depending on your specific implementation. You can play around with this as much as you want. This thing here, though, is pretty interesting. It's part of the proxy interface. This is the part that actually appears in the calculation view. And per default, this is a DS part, so a data symbol part. If we subclass this, we can change the behaviors of the part and display other things. In this case, I've replicated most of the behaviors, but to highlight one of the things that I think might be pretty common that you want to do, I've chosen to change the article codes from that of the catalog. Catalog, as default, has a way of building up part numbers depending on what features you set, but that might not always align properly with what the customer wants their parts to look like. Maybe you need to set up the options in a different way in the catalog to make it user-friendly, and maybe you still want it to look the way that it used to. So you can change the parts, and in this case, I just subclass the part here from the one that we used originally. And once again, maybe not the best programming practice, but to highlight what you can do. During the construction here, we go into the data of the part, not related to the DSP data. We check the article code. If it's an engine section, we want to call this a mod engine. If it's a middle section, we change the article code to mod middle. And if it's a nose cone, then we change it to mod nose. And hopefully, if I've done everything wrong now, right now, hopefully not wrong, and we press F5 here to reload the part. That didn't work. Let's try it again. There, we have a different part. Usually you don't do changes once it's submitted to a user. Okay, so you can change the article code. You have access to the entire part. You can do whatever you want with it, and you don't need to, like with all the other proxy things, you don't need to set up another snapper. You don't need to set up another DSP data. It's still using the catalog stuff. It's just that we have changed the behaviors just a little bit to fit our needs. All right. So far, so good. Let's keep this here. I like that. Other things. The whole interface is, of course, in the base class. So you just overwrite it and use it. Loaded one was one that I got a special request that I should probably highlight. This is really common that if you change something in a part in the catalogs or your company has upgraded something, then you can change the way the data symbols load, and that can be useful for a number of cases. Yes?
That would be good for seeing how old drawings and they were corrupted and see we got a new code, we want to override those.
That's right. Changes. Yeah. So maybe you had this certain article code, P engine something. Now this article is not valid anymore, but your customer still has a lot of drawings out there with this old article code, and then loaded 0, then we can go in. Okay, so I don't want this article code. Change it to this other, just like you said. To enable which proxy you should use on the DSP data, you have one of these proxy register. You register these on a catalog basis. In our case, I've just said that, okay, which proxy are we supposed to use? Always use this proxy, but you might very well want to do some sort of structure here where you say that certain part numbers should have this proxy and other part numbers should have this other proxy. You have the DSP data here to differentiate between which one you want to use, and you can do what you want with it. But it's appended like this. And this is done, I set it up during the initiation of the extension. It might very well be possible to do it during start or through some other hook. And then this one is called, it initializes the proxies. Append DSP data proxy register. And this is the enterprise code of your catalog, so that catalog will always use this register that you saw on the previous one. And that will use this data proxy. Any questions on proxies? Otherwise, we're going to move on to the to PGC snappers and how to augment them with data objects. All right. So let's check that thing out. And we'll go to PowerPoint again. Okay, since it's an interface on the proxy, it has to be pre-coded. You can't just change the interface, it's done in the base classes. So you're going to eventually run into things, okay, we want to do more than just what a data symbol can do, and in which case you implement a PGC snapper that you append the same data that the data symbol, which is the snapper used by Catalogues. You do the same thing, and when that's done, you just get things from the data. Like, give me the 3D, give me the parts, give me detail masks, give me this or that. Or what you need to do is you need to append the data object to your new snapper. And in this case, we're going to use a model 3D snapper as an example, because it's pretty basic. It just has a model and it's a good example class. And when you've appended it, you use it. Here you can see how a data symbol is structured. You have multi-data. So there are two components to data from catalogs. You have the multi-data, which is a container where you put other DSP data. And the DSP data, that's for data symbol product data. So that's where the information is stored. The multi-data is just a wrapper, a container that allows you, like, give me all the parts of all the sub DSP data. So the multi-data is, it needs to be there, but it's just a container. It doesn't hold a lot of behaviors by default. Yeah, and this is an image of the container. You have the multi-data, which is a DS multi-P data, and you have the sub-data, which is DSP data. You need to init the multi-data, and then you need to init the sub-data, and then you need to append the sub-data to the multi-data. These are some of the things that you can get. Connectors, not supported a lot right now. Bounds you can get, you might want to cache that, but all the other things are very handy to get. You get the graphics, you get the quick properties, domains and values, materials, and your parts. Basically, those are main things that you can get from the data. There's a ton of other, but I can't go through all of them. Yes?
What is the difference between quick properties and snapper properties?
Quick properties are the ones on the snapper. Those are the ones you see at the side.
Yeah, on the side.
And I think that the base class for the ones used by data symbols, they are called sidebar properties. Yeah, so I think that's I don't exactly know the difference between them, but they are different classes that do the same thing basically.
Yeah, because initially when we started, we had quick properties and then we had the sidebar properties.
Yeah.
Or like, well, we may as well put them in one dialog.
Yeah, and I think this is a step in that direction. Sidebar properties are really practical because you can use them easily as animation properties.
Yeah.
Which I don't think the original quick properties were. Then you need to use like animation properties. So I think sidebar properties, it's meant to encapsulate it. Maybe it's a future further developer, but I'm not that knowledgeable about that exact, differentiation. But the ones on data symbols are sidebar properties. Okay, so let's take a look at how you can set up a catalog snapper. Here's my Model 3D snapper. Extends Model 3D snapper. Model 3D snapper, as you might know, has nothing to do with catalogs per default. So it's a clean sheet. I usually start in the constructor initializing the data, because some of the constructor's methods and calls that are being executed might want to use the data, like for instance your initial width, the initial material that you apply can be good to have. So I usually run this first, but feel free to move it around if you feel that's more convenient. Here is the data. I've set up a few methods, getters and setter methods, and whether or not getters or setter methods are the correct way to do things is not going to be debated during this presentation, but we have a setter here. It's a DS multi-p data. We have a getter here, and that's just to shorten the code, basically. These are stored on the properties of the snapper, like in the previous slide, and it's just a get and set to the properties. We have a default one, just straight out of the box. As you can see, there are no input parameters on this because it's really basic. It's a container object. If you have one of these multi-data, then we use our own data, and I've set up a method for this, or a function for this, that we can call everywhere from. It's just to say that which catalog is this DSP data supposed to come from. If you just use a table of contents for a data symbol, that is going to be sorted out by the button, basically. But in our case, we need to define a few things. Enterprise code defines which catalog you use. Vendor code, that's also defined to define the specific catalog. We have the article code, which could be like P engine section, it could be P nose cone, whatever they are called in the catalog. I've always defaulted here to nose cone. I think you should always have a valid part as the default. Probably a good practice. Correct me if I'm wrong. And then you have the product catalog code, which is like subcatalog. This is connected to the price list being used in the catalog. And then we set the default options defined in the catalog, and that's basically it. We got the DSP data as it should come out of the catalog. And then we append this to the multi-data. We put it. The multi-data is also a prop ob, so you can just use the put method here. Default, this is the key. Since we are stacking up a lot of DSP data under the multi-data in the container, they're defined with their keys. So if you want to get a certain DSP data, which is linked to a certain product, like the engine, for instance, you're going to access it through the key. In this example, we only have one DSP data per multi-data, so it's always going to be the default. So instead of writing, get data with the key default, we say that, okay, so if we write data, then we get the default. It saves a lot of lines of code. So this is how you set up the data. And once you've done this, when you initialize the snapper now, it should have the data available. And at this point, we can start getting things from it. Do we have any questions on how to initialize the data? Nope. Okay, then we're going to look at how to get things from the data. To do this, we are going to take a look at how it looks straight out of the box. And we're not going to use this demo one, we're going to use this one. And this is the same thing. I've set up the same thing, a library with buttons that creates the snapper, the different snapper types. I've subclassed the one that you saw earlier into 3 different ones. So we have one for the nose cone, one for the middle section, and one for the engine. And they all have their different article codes linked to it, and they get their data created. So if we just want to place this thing right now, you can see it's a red box, and this is because I decided to write to print out the local bound. So we can start with getting the local bound, because this is not what that part's local bound should look like. It should be smaller. So we can get the local bound from the data, and if we just comment this thing out, I've prepared an example of this. Here we go to the default subdata, and we get the local bound. This is not cached super well, so if you're doing this alone, you're probably going to want to cache the local bound here, or just set up a heuristic like the one above to encapsulate your snapper. But as I said before, I'm not focusing on the best programming practice, but on readability, and I want you to get the grasp of the basic functions here. So using this local bound instead from the data, we should see in the extension that this thing grows a bit smaller because it's based off the model. And there we go. It's a little bit smaller. Should be able to fit this thing because this is the same. Connect local bound, new things for 8.5 that you need to make sure to include all the snappers. I thought I'd change this thing. We don't want to loop this, we just want to expand it a little bit to make it a lot faster. But in our case here, I looped over connected. Build 2D, we can just run data, build me the 2D, and we append that to the graph of this model 3D snapper. Same thing, you ask the data, give me the 2D, and it's going to give you the 2D. So hopefully it should have the correct 2D if we swap to the 2D view. This does not look right. Okay, that's unfortunate. No idea what that happened. But as you saw, there was 2D, which is better than nothing. We have the detail mask also. We can ask that from the data here. I return super instead. This will then use the different LODs of the model being used, and if there, for instance, isn't a super high res model, then it's not gonna put that into the detail mask. So it's pretty practical in that regard. But we want some 3D, and we're gonna get it. Hopefully this time it works. After that data, get me the 3D, and hopefully it should give us the 3D. I'll disable the local bound made of red wine here to highlight the change, and hopefully we should see the 3D appear now. There it is. Now we have this here, but if I remove this thing here, you see the quick properties that came up for the data symbol. I don't think we're not gonna see this on our model 3D snapper because we haven't defined it, and I think you're getting a hang of it right now. To get the properties, we get those from the data as well, and hopefully they should show up now. But here we have so if we refresh them, we have them here, but nothing's going to happen if I flip it to blue, because we also need to, when we set it, we also need to update the data with that value. That's what we do here. Hopefully now it should swap to blue. So we're basically making it closer and closer to a data symbol. The good thing about this is that now we can implement whatever behaviors we want on this snapper, because it's not part of core and it's local to our extension. So we're basically setting up our own playground here by just getting the things from the DSP data to help us with that. Now if I change this to orange, hopefully it should turn orange, and there we have an orange one. Yes?
So when you change a sidebar property, basically what's happening is that it's calling data.put in the background.
In this case, we append the properties of the snapper. So what you see here when we click this one, these are the properties of the snapper. And that is going to call try-set property on the snapper. And that's what we then connect on the try-set of the data. So it's going to act exactly like the data symbol, but it's not the data symbol.
Now, if you want to do it through code, say you wanted to change orange through code instead of using sidebar properties, when you call data.put, it kind of does the same thing as try-set property, does it not?
Yeah, I think it's... Okay, I'm not 100% certain, but I think it's going to go through... No, it's not going to go through try-set, because it's not an actual sidebar property. I think it's just going to... If you write in code, you're gonna go into the data, say put, and then whatever.
The feature key.
Yeah, exactly. The feature key or the group code of that feature, and then the code of the option you want to set. That should not call try-set property, no. We could possibly try it if we have the time at the end of the session. How much time do we have left?
10 minutes.
10 minutes. So, yeah. So those are some of the basics. I said one of the things that Catalogue currently doesn't support are the connectors, that we cannot have intricate connection behaviors as of right now. We have male and female connectors, basically saying that you cannot connect them in however you like, but it's pretty limited. And for my case here, I wanted to highlight one of the things. To set up a rocket stage like this in Catalogues, we're going to need two different connectors here to allow that you cannot put the nose cone on the base. For instance, these have different connectors, or it's a different female-male connector, which means that we have one connector that allows this thing, but on top of the cylindrical here, we actually have two different connectors with two different codes, which allows us to place both a nose cone to snap and this one to snap. But there's no actual check here. There's no actual check to say that you're not allowed to snap in the middle here. The connector is still there, but there isn't any logic to prevent that. I wanted to change that on the Model 3D snapper here. So what I did was I set up the PPC behavior basically to first I set up connectors similar to the ones in Catalogues. This is right now, it's not supported 100%, so I stole the code from data symbol here and did the same thing. But I spoke with some of the creators of Catalogues, and they say they're going to take a look at this, make sure it's just the same process, data.get connectors, and you get the connectors. That would be really handy, but right now this is what we have. So we set up the connectors as they're defined in the catalog. We append them to the snapper, and now we can do whatever we want with them. So for the subclasses of this, so if we look at the middle section here, I can define my own allow attach behavior for those connectors.
So basically I can check here if the middle to nose is connected, then do not allow attached to anything else, which then would prevent multiple things to snap to the same place in this extension. Let's hope it works. I haven't checked this out for a few days now. Okay, so now we can't snap one in the middle. That's a pretty neat feature. It's pretty common that you want to define the connection behaviors depending on other connections that you've made already. Well, let's see here. Do we have any questions on this that we've gone through? Any other things we'd like to show? Otherwise, we can take a look and see if we can.
I do have a question, but
yeah.
I don't know how busy you are, because it might take a while. Maybe after.
Yeah.
Okay.
Yeah, we have to. Okay, so let's see here. If we want to change the data. I haven't tried this out. Oh, here, tooltip, another thing you can get from the data. Right, here. I forgot an important part.
Get parts.
Exactly. This one ties into the multi-data. It's a container. It doesn't have, a lot of behaviors per default. But one thing that's really practical to use the multi-data for is parts getting. So if you append a lot of DSP data to this particular snapper, multi-data, if we ask multi-data, give me the parts, it's going to give you the parts for all of them, and not just a certain subdata. And that's just what I do like this. So multi-data, get parts. The full interface is of course in the DSP, DSM multi-data P. Gee, that's a tongue twister. DS multi-P data. If you check this one out, you're gonna see the full interface. And if we do this, just get all the parts for one, we should see the parts appear for this rocket, and we should have two middle sections. Do we get two? Yeah, we have two middle sections. So, and as you can see here, it doesn't say P engine engine section, but it actually says mod engine. And that is because we're still using the same proxy that we set up earlier. All the DSP data related to this catalog are going to use the same proxy. So we can actually do this gradually without risking a lot of rewrite. So you set up a catalog extension as a new company coming in, or as somebody that wants to upgrade to a catalog solution. You can set up a catalog. You can get a minimal viable product, basically. You can place your things. You might not be able to do all of the connection behaviors that you really want, but at least you can try it out. You can play around with it. You can get a better feel for what you actually need. Once that is done, you can set up a proxy. So you can play around with that. What can we do with the proxy? We can change the parts. Okay, this might be enough. For the extension we want to do. This might very well be all we need, and we can save a lot of time in programming. But if we want to take it one step further and actually implement these snappers like this, we can still use all of the things that we already have. We can use the catalog to get our domains and data and materials, and and we can use the proxy that changes article codes or what you want. And then we can just add, for instance, if it's connection limitations that you want to the snapper. So that's what I intended to present today. Do we have any questions? Let's run a bit of a Q&A if there are questions. I know you had the question, but it was a long one.
Yeah, it's a long one.
Yeah, we'll take it after this section then.
We can ask a question and
and then if someone else is interested in the same thing, you can ask if everyone at the same time afterwards, right?
Sorry?
So if you ask a question now, you can answer him afterwards, and if someone else is interested, they can join. Right?
Yeah. Yeah, that's a good idea.
Okay. So the problem I'm having is, so your snapper properties there, like the hull, the finish for the rocket was only, it's not nested, it's just kind of, as soon as you, like if you were to pull the rocket in right now, you can see that there's no nesting at all.
We don't have any nesting in this.
No
No,
materials. So
Yeah.
say you have so for our products, they're quite nested.
Yeah, that's usually the case.
3, maybe even 6 levels. So if you wanted to, what I'm trying to do is I'm trying to use the scheme manager as well to put the data, and basically by getting the lowest level finish material,
Yeah.
get that path for that tree, material tree view item,
Yeah.
or whatever. So how can I generate the path for that data by calling data.put with the lowest level?
You use a group code for that,
But what if, like,
I think.
maybe I should bring my computer. I'm having issues with it because even though I do have the group code set up in the catalog,
Yep.
and I'll call data.put and then the material code, but because it's so nested and so many different features,
Yeah.
it's saying not in domain or not in domain. I'm calling data.put.
We have the similar kind of issue. I'm not sure, but when you say about tree, normally this will happen if under your material feature, there is further some tree.
Yes.
Yeah,
That's right.
So what happens is when the option is getting changed, the new tree which is coming under the new option now for that feature, that gets initialized to the default options rather than remembering the old tree. So I think to override this behavior answer is already in play. You remember what tree is there underneath, and once that feature has got new option set in the super, try to
Try to reapply the same.
Apply the same tree underneath to the new set.
Yeah.
One
Would that work?
more scenario I found maybe when you are changing the property of one of these stacks, you might need to do that for the whole stack.
And that's what I also want to look into is when you change a sidebar property. If I could, maybe I need to go behind the scenes more into the core code, but if I could get or look into tricep property more, because obviously that's working. So say you have finishes up, I have finishes for a chair, and they're all nested. If I select the lowest level one, even though it's nested, say 10 options, it works. But then when I try and do it through data.put with the scheme manager, if I could mimic that, then it would work for me perfectly. Maybe I need to go in the core code more. It's very
Exactly. You could take a look at that. I would think that if you run just data and then put, you write the group code then to differentiate between all the others, and then the code. And if the data is initialized, then I don't really see why that shouldn't work. It should. I mean, I can understand why the rest of the tree gets, disappears when you change the base. But why it doesn't? It should work.
I think what's happening is because they're obviously not all of the same group codes. Say you have, for example, in rocket, you have hull material, and then maybe it goes down to another level and then another level. And each feature has a different group code. Because I don't think it's a good practice to make them all the same group code.
No, they shouldn't have the same group code. If you have the same group code, the algorithm is basically not going to know which thing you actually want to change with the code.
Exactly. So say you have orange, now you want red, but red's in a different feature with a different group code. How do you get that path, or how do you get that group code that's selected?
Yeah, I have the same problem actually.
And with the scheme manager, I only have access to the material code selected. With that, so
you can ask the you can brute force this, of course, but it's not beautiful. You could just check all the group codes until something is out.
And my head's been spinning, so I kind of took a break from it.
Would it be possible for you to send in a feature request for this, or ask dev support?
Yeah, for sure.
Yeah.
I think I need to play around with it more. So.
All right. Okay, so I think we're out of time. Thank everybody for showing up. It's been a pleasure.